Hello guys, today we will discover why the ice in Greenland is melting so fast. So we will be here Mr. John from Tomorrow News telling us why it's melting. Okay, let's see.
New study reveals cause of glacier melt in Greenland. During the summer of 2015, Greenland experienced its highest rate of glacier melt ever recorded. A study shows the record-high melt is linked to the effects of a phenomenon known as Arctic amplification. Arctic amplification refers to the faster warming of the Arctic compared to the rest of the northern hemisphere as sea ice disappears. It is fueled by a feedback loop. Rising global temperatures are melting Arctic sea ice, leaving dark open water that absorbs more solar radiation, further warming the Arctic. According to the study, the atmosphere and the oceans combined are contributing to the melting of vast ice sheets off the coast of northern Greenland. The effects of Arctic amplification are unknown, but scientists believe it can change the Arctic jet stream flow, which circles the northern latitudes. Jet streams are narrow bands of strong winds in the upper atmosphere that follow the boundaries of hot and cold air. In the Arctic's case, frigid polar air is separated from warmer air in the south. A slowdown in the jet stream would cause wilder swings and allow it to bend farther north than usual, creating a high-pressure system called a cutoff high. The cutoff high draws in warm air from lower latitudes, leading to greater ice melt conditions. The study found that during the warmest summer in Greenland, the jet stream reached latitudes never before recorded during that time of year. The Arctic amplification is now cited as the cause for the melting of Greenland's ice sheet, which is the Earth's second largest after Antarctica.
Okay, after we hear Mr. John tell about why the ice melting so fast. Now let's see what the scientist telling us about this.
A group of researchers are taking the closest look yet at a quiet but critical process.
To measure water on the ice sheet, our group uses an instrument called an acoustic Doppler current profiler, and it's this little cone-shaped instrument that we put on the bottom of it. Looks like a boogie board. We strap it in the middle of the boogie board. It sits just below the surface of the water, and it tells us how quickly the water is moving, and it tells us the depth of the water across the channel.
All this meltwater is generated throughout the catchment, and you can see all the way up there, and it flows and accumulates in a number of rivers, makes it through this river, and then flows into a giant muon down there, which enters the ice sheet.
We can use satellites to map rivers on the surface of the ice sheet and rivers that are draining the ice sheet, and the satellite measurements in concert with our field measurements, or when compared with our field measurements, can help make them more general. You can look at certain characteristics from satellite images, like width of a river, and we know that widths tend to vary. If the river is wider, we generally can assume that there's more water flowing through it. So you can look at different characteristics that you can measure from satellite images and compare those characteristics or validate those characteristics with the measurements you make in the field.
Okay, so behind us we have a Tyrolean traverse system, and so that's being used to operate what we call a hydro board. It's a board with an acoustic Doppler current profiler. That's telling us how deep the water is, how fast it's moving, and what the cross-sectional area of the channel is. So with all those three parameters combined, we can it tells us exactly the volume of water passing by us each second, which at this current moment is about 10 cubic meters per second. So when we measured it this morning, it was about 5 cubic meters per second. That was at 11 a.m. And so now, a few hours later, we've doubled that flow. The depth's increasing, the velocity's increasing. And this will...
After here, some scientists advise we will see some solution to help us prevent global warming. Here's some solution: starving, reduce CO2, grow trees to stop global warming. This is the end. Thank you for watching this video.